Good morning to Sir Muhammad Hazim Fahmi bin Muhammad Ghaffar. Today we want to present about vector and scalar in mechanical engineering. My name is Muhammad Haziq Aiman bin Osnan. My metric number is 20DKM21F1013.
Okay, my name is Muhammad Hanif bin Jainan. Then my number matric is 20 DKM 21F1088.
And my name is Aim Afizullah bin Nazarni. My metric number is 20DKM 21F1057.
And I am Adam Akasha Muhammad bin Sufyan. My number metric is 20 DKM 21F1052.
Introduction of vector and scalar. Vector are mathematical entities which have both a magnitude and a direction. Second, note that the location of the vector, for example, on which point a specific vector force is acting or where a car with a given vector velocity is located, is not part of the vector itself. Last, physical example include force, velocities, momentum, and locations. For scalar are mathematical entities which have only a magnitude and no direction. Physical examples include mass and energy.
Right. We'll talk about the application of vector in engineering. Right, the vector are used in engineering mechanics to represent quantities that have both a magnitude and a direction. Second is many engineering quantities such as force, displacement, velocities, and acceleration will need to be present as vector for analysis. And the last one is vector quantities contrast with scalar value such as mass, area, or speed, which have a magnitude but no direction. Right, that's all.
Okay, now I will talk about the formula. So this is a formula for vector and scalar. The first one is a unit vector. Unit vector is vector u equal u over magnitude u. Then the second one is cos theta equal a dot b over magnitude a times magnitude b. Then the third one is a scalar product, where is a dot b equal to a1 times a2 plus b1 times b2 plus c1 times c2. And the vector product is where a times b equals to the determinant method, and the last one is area of parallelogram ABC, which is magnitude AB times BC. Yes. And now I will present about mathematical solution with theory. So this is a picture state that we can use a dot product that we learn in chapter 5, that is vector and scalar, to find the dp between the A and B. Okay. So now the solution is find the angle between a vector A equal pi plus oj and vector B equal phi I minus 2j. So A dot B equal open bracket pi plus oj close bracket dot open bracket phi I minus 2j close bracket. Then the answer will be 50 50i square minus 8j square. Then if they got a square, we need to replace the j square and I square to 1. So it will be 15 times 1 equal 8 times 1. So the last answer would be 7. Next. So now we will use the formula that cos theta equal A dot B over magnitude A times magnitude B. Then we just find the A dot B is 7. So we will find the solution to find the magnitude A dot magnitude B. And now magnitude A is equal square root 3 square plus 4 square. And the answer will be 5. And for magnitude B is square root 5 square plus negative 2 square. And the answer for magnitude B could be 5.39. So the cos theta equals 7 over 5 times 5.39. Then it will be cos theta equal 0.260. Then we will move the cos to the right side. So that will be inverse cos open bracket 0.260 close bracket. Then the last answer will be 74.93 degrees. Okay.
Okay. Find A dot B when A equal I minus 2j plus k and B equal 3I minus 4j minus 2k. Second, A equal to I plus 2j minus k and B equal 6I minus 3j plus 2k. The solution is given A equal I minus 2j plus k, B equal 3I minus 4j minus 2k. A dot B equal open bracket I equal I minus 2j plus k close bracket dot open bracket 3I minus 4j minus 2k close bracket, and 1 3 minus 2 2 4 plus 1 negative 2, and 3 plus 8 minus 2 equal 9, and the final answer of A dot B is 9.
Yeah, we move to the next question. Is as you can see from the diagram, we have to find the answer for the question. The question from the diagram triangle is find the term of U and V for the A, RQ, B, RN, and for the last one is C, PN. For the solution to the question A is PQ equal RP plus PQ equal negative PQ plus RQ equal negative U plus UV 2V, and for the last answer is for the negative U plus 2V is 2V minus U. We move to the next question. For the B question is Rn equal 1 over 4 equal 1 over 2 bracket 2V minus U, and for the last answer is 1 over 2V minus 1 over 4 2. For the last question is C is Pn equal Pr plus Rn equal U plus 1 over 2 V minus 1 over 2, and for the last answer is 3 over 2 4U 3 over 4U plus 1 over 2V. That's all.
Right. We move to the another question. Right. Question is, if D and E are the midpoint of the side AB and AC of a triangle ABC, prove that PE plus DC equal 3 over 2 BC. Right, the solution is let the position vector of the vertices of the triangle ABC be A, B, and C respectively. So OA equal A and OB equal B and OC equal with C. So as you can see the diagram, triangle diagram, right? Since D is the midpoint of the side AB, right? OD equal, this is the formula, OD equal with A plus B over 2, and E is the midpoint of the AC. So OE equal with A plus C over 2. Right, we move with this. BE equal OE minus OB equal A plus C over 2 minus B equal with A plus C minus 2B over 2. Right, the next is DC equal OC minus OD equal with D minus A plus B over 2 equal with 2C minus A minus B over 2. And the answer BE plus DC equal A plus C minus 2B over 2 and plus 2C minus A minus E over 2. The next is A plus B minus 2B plus 2C minus A minus B over 2. Right, equal 3C minus 3B over 2 equal 3 over 2 in bracket C minus B. So the answer for 3C minus 3B over 2 is 3 over 2 and in bracket OC minus OB. And the last answer BE plus DC is equal with 3 over 2 BC. Alright, that's all for the question.
For the conclusion is, vector have a crucial role in our daily life as well as in engineer mechanical. Vector are used to express quantities that have both a magnitude and direction. For the analysis, many engineering quantities such as force displacement, velocity, and acceleration be represented as vector, and other than that, a scalar is a physical quantity with magnitude only, and a vector is physical quantity with a magnitude and direction. Vector may be represented as arrow, where the length of the arrow indicated the magnitude and the arrowhead indicated the direction of the vector. That's all.
Okay, thank you. Haikal, do you have any question for us?
Okay, I got plenty of questions to ask with presentation slide. Okay, Haziq, can you give me what is an opposite vector?
Okay, the opposite vector is two vectors are opposite if they have the same magnitude but opposite direction. So two vectors and are opposite if two vectors are parallel is they have the same direction but not necessarily that same magnitude, or anti-parallel if they have opposite direction but not necessarily that same magnitude.
Okay, so the second question is a distance a vector?
Whereas displacement is defined by both direction and magnitude. Distance is defined only by magnitude. Displacement is an example of vector quantity. Distance is example of a scalar quantity. A vector is any quantity with both magnitude and direction. Okay.
So okay, and Adam, I want to ask you something. The first question that comes in my mind is, what is the length of a vector?
All right, thank you for the question, Haikal. All right, what is the length of a vector? The length of a vector is the square root of the sum of the square of the horizontal and vertical components. If the horizontal or vertical component is 0, if A or B is 0, then you don't
Seems like Adam is stuck. It's okay. Can we just skip to Hanif? I want to ask question for Hanif. So I'm very curious about the slide, which is a very good presentation slide actually. But I'm curious about what is who introduced vectors? Okay, Hanif.
Oh, thank you for the question, Haikal. So, the vector is appear late in the 19th century when Josiah William Gibbs and Oliver Heaviside of the United States and Britain respectively independently developed vector analysis to express the new law of electromagnetic discovered by the Scottish physicist James Clerk Maxwell, and since that time, vector have become the essential of physics, mechanics, electrical engineering, and other science to describe force mathematically. Just that.
Okay, thank you for your answer, Hanif. So, Aima, I have two questions that I am very curious about. So, what is a vector in simple terms?
Okay, for the vector in simple term is vector is specific and a quantity that has both magnitude and direction. It is typically represented by an arrow whose direction is the same as that of the quantity and whose length is proportional to the quantity magnitude.
Okay,
That's
the
for the answer
second,
for the simple term.
okay, the second, okay, the second question that comes to my mind is, what is the difference between vector and scalar? Can you give me an answer?
The difference between vector and scalar is um, scalar are quantities that are fully described by a magnitude or numbers. Vector are quantities that are fully description by both magnitude and direction. That's all I guess.
Okay, thank you. Thank you, Emma, for your answer.
Haikal, can you ask Adam again?
Okay, Adam. Uh, for the for the first question that I asked you before, what is the length of a vector?
All right, thank you. I'm sorry for the problem. Again, I want to talk about what is the length of a vector. The length of a vector is the square root of the sum of the square of the horizontal and vertical components. If the horizontal or vertical component is 0, if A or B is 0, then you don't need the vector length formula. In this case, the length is just the absolute value of the non-zero component. Right? That's all.
Okay, the second question is, What is vector in mechanical engineering? Can you give an answer?
Right, thank you. What is vector in mechanical engineering? Right, vector are used in engineering mechanics to represent quantities that have both a magnitude and a direction. Vector quantities contrast with scalar value such as mass, area, or speed, which have a magnitude but no direction. The force below is represented as a vector. It has above a magnitude and a direction. Right, thank you. That's all for me.
Okay, that's all